Okay, so we got an intersection here at, this is actually t. We had to put in x instead of t. So 165.538, and what was our time measured in? Does it say to the nearest second? So we would actually answer what, 166 seconds? And Megan, what would you have to show on your paper if you solve the problem? You need to show the graph, and probably the window would be a good idea. I have it down there, but you guys can do this one. And then the question about solving it just off of the equation, you can do that. You would take 3,000 plus 18x to the 1.4 and set it equal to 26,000. Subtract your 3,000. So that would equal 23,000. Divide by 18. I'm going to have to get the calculator for that one. 23,000 oops, put my pen down. 23, come on, 23,000 divided by 18. So 1,200, I'll bet this won't stay. Now, do you know how to take the 1.4th root of that? Yeah, you do your root number first. 1.4 math 5. And I'm just going to use answer so that because you don't want to round and retype. That makes you lose accuracy. And did we get the same answer? Well, we sure did. Okay? So a couple options there of doing something like that. The quiz, the two-problem quiz, question like this would be, it's all calculator, has to be. The question on the quiz gives you an equation, you sketch the graph, you have to label your axes, put like, put time on your x-axis in seconds or hours or whatever the time is, and then you're going to put this velocity on your y-axis. Then you show a strip, like we did in the very first. You draw that little strip and put dt and t and v of t. We're not quite to the part where you write the equation yet that you're going to be doing, and a definite integral to find the exact displacement. So this part here, not necessarily tested, but it is on the assignment today. But you do have to find the integral. Is this it? Is this the last one? Oh, we have a 9. Okay, how far does the spaceship go from the time the last stage fires until it reaches orbital velocity? So, they started time, if we go back, I think they started time when they fired that rocket, so we'll start at 0. And if we are wanting the total distance, can we go directly to something that will get us that? Like, we worked through several things. What? The original equation, and what are we going to do to the original equation? Find the antiderivative. We already did that for 0 to 100, but this time it wants us to go from till it reaches orbital velocity. And in the last question, they had us round to the nearest second for how long it would take to reach orbital velocity. So what's my other bound up here? 166. So we're going to do the same problem again. Your v of t, what was that? 3,000 plus 18t to the 1.4 power dt. And we already did the antiderivative. I tried to get Mitch to help me, and he wasn't cooperating. That's a 2 right there, by the way. And that we can just plug in, can't we? Do you want me to go back through plugging in as far as, or can we just do a Math 9? Are you okay with the fundamental theorem? Ants, yeah, ants. I don't know. Felix thought I said ants. I kind of sort of started to. I started to say antiderivative and fundamental theorem all at once. What did you say, Felix? Are you being mean? X 0, 1. It's thinking. Good grief. It's a big number, yes. Yeah, it does. But that's why it gives you the antiderivative. You have to plug in the original, though. Oh, yeah, this calculator won't. You can't just plug in 3,000 plus 18t to the 1/4 and tell it to find the antiderivative and have it come up with 3,000t plus 18t to the 2.4 divided by 2.4. It won't do that. Yeah, it has to be a definite integral for the calculator to handle it. So 2,095,057.949, and that's feet. And if you divided that by 5,280, it's actually, let me just tell you, it's 396.791 miles. And that's in just under 3 minutes. Pretty fast rocket. I think actually, let's see, number 9. Are you guys good on 8 first? Based on what you observed while doing this exercise, why do you suppose integrals are written in differential form? In other words, the antiderivative of f of x dx instead of simply the same thing without the dx in it. Now this is what I was trying to explain. I did this a little early because you asked me that question, and that's been a while. But we said that dx originally gave you directions. It told you what you're finding the antiderivative with respect to. But can you now see with these drawings where I did the little strip of, well, good grief. There it is. This piece right here, that dt is the width and the function v of t is the height. So that's another reason that we have to stick that d of t on there. It's not only directions, but it's also giving us the width of that rectangle. And as you find areas, you no longer put the separate pieces in it, you just put the answer. I will